Lesson 15 is on percent yield, which is again another honors concept. So what is percent yield? And we're going to try some practice problems. A stoichiometric calculation will predict the amount of product that will form during a reaction. This is called the theoretical yield, which is obtained from our balanced equation. An actual yield is the amount of product that is actually produced when the reaction has been completed or obtained from actually running the reaction. The percent yield is the ratio of the actual yield to the theoretical yield expressed as a percent. The percent yield is a measure of the efficiency of a reaction carried out in a lab. Remember, we do have some room for error in a lab setting. So this is the equation. Actual yield divided by theoretical yield times 100 is equal to the percent yield. This is not in your reference table.
So in this problem, we have a balanced reaction below, which is 1 mole of oxygen plus 4 moles of carbon gives you 2 moles of carbon dioxide. You have 2 moles of oxygen gas are placed in a reaction vessel with an excess amount of carbon. If 3.5 moles of carbon dioxide is being actually produced, what is the percent yield of this reaction? So the first thing you have to do is look at your mole-to-mole ratio. If 1 mole is equal to 2 moles, or 1 mole of oxygen is equal to 2 moles of carbon dioxide, we are now looking at our actual yield, which is 3.5 moles. We actually produce this. But when we look at our ratio, if we're using 2 moles, therefore we should in theory get 4 moles of carbon dioxide. That is a mole-to-mole ratio. So therefore, we could say with our actual and our theoretical that 3.5 over 4 times 100 tells us that 87.5% of our product was created. We lost the other 0.5 moles, or the other 12.5%, somewhere in the chemical reaction. In this problem, again, we're looking at a balanced reaction of 1 mole of nitrogen plus 3 moles of hydrogen gives you 2 moles of ammonia. You have 5 moles of nitrogen gas, and they are placed in a reaction vessel with excess of nitrogen. If 9.3 moles of ammonia gas is actually produced, what is the percent yield of this reaction?
So if you think of this in terms of steps that you have to carry out, you're first going to want to do the mole calculation, the stoichiometric calculation for how many moles of ammonia gas you end up with. And then you're going to go back into the question and find the actual amount produced. And step 3 would be to set up that percent yield formula.
So you're noticing in your mole-to-mole ratio, it is a 3-to-2 ratio. But in your problem, your actual is 9.3. You're not going to actually put that in your ratio. But you're using 5 moles of hydrogen gas. So if you were to make a ratio, that's 5 times 2, which is 10. 10 divided by 3 tells us our answer is 3.3 moles of NH3 gas. So in theory, we made 3.3 moles, but we actually produced 9.3. So when we go into a percent yield formula, we're noticing that we somehow created 282% more than we should have. So now the question lies, did you or did the person do something wrong in their chemical experiment?
Now this could be in terms of measuring the amount of grams of hydrogen that you used, or it could just mean that you actually didn't produce all that as just ammonia gas. It could have been something else.